Okay, we're up and running. Here we go. We're given a circle that goes through the point negative 7, 4, and the y-intercepts of positive 11, negative 13. So we are going to do a bunch of plugging in to our general equation for a circle, which is x minus h squared plus y minus k squared equals r squared. Okay, now if you don't want to, don't take notes on this. This will be available online tonight. Okay, if you want to just watch, if taking notes helps, then take notes. Okay, so general equation for a circle, negative h and negative k. Remember our counterintuitive, if this is minus 3 and this is minus 5, yeah, go ahead, JD. Yeah. If this is negative 3 and this is negative 5, what are the center coordinates of that circle? 3 and 5. It's counterintuitive. It's like factors and roots. Okay, so now, first step, we know coordinates 0, 11, and 0, negative 13, correct? Why? Because those are y-intercepts, and y-intercept is not just 11 and negative 13, it's 0, negative 13, and 0, 11. Okay, so that allows us to substitute those in, all right? So we can substitute in. The 0 can go for x, so we can go 0 minus h squared plus ordered pair 0, 11 minus k squared equals r squared. Okay, also we can do 0 minus h squared plus ordered pair negative 13 minus k squared equals r squared. And then we can set these up to be mortal enemies and subtract everything. Okay? And this is nice because what is 0 minus h squared minus 0 minus h squared? 0, and we love 0. I should go red again. So we got 0 there, plus, I'm not even going to multiply these out yet, but I will. 11 minus k squared minus negative 13 minus k quantity squared. And then what's r squared minus r squared? Equals 0. Is that okay? Now, why is this a good technique? Why is this a good technique? Marissa, why is this a good technique? No. You do know. Don't be saying I don't know. You know that makes me crazy. I'm going to do the bad boyfriend speech. I know. A bad boyfriend. They're not all abusive. But you will, probably all of you will have a spouse at some time that's just not right in one way or another, right? And you're just going to go, plenty of good people out there. I'm out of here. I'm going to date someone else, right? So you do know, Marissa. Okay, why is 0 really good right here? Think about it. Right, I eliminated one variable, and that's a good thing. And you do know. Confidence. Posture. That's what you need in math. Forget brains. Confidence, posture, and hard work. That's all you need. Okay, here we go. So we eliminated the h variable, and that's a good thing. Let's expand this a little bit. And somebody yesterday in 6th period said 11 minus k squared is 121 plus k squared. And I was just like, what in the heck are you saying? I just about went ballistic. Well, and you got to get that B term as well. Okay, so we're going to FOIL this. 11 times 11 is 121 minus 22k plus k squared minus negative 13 times negative 13. Not. Carry the 7. 169 minus 26k, and check me on this because I'm going fast today, plus k squared equals 0. And notice this negative is going to distribute, so we got to be careful. All right, 121 minus 169. Negative 48. Minus, okay. Careful, careful, careful. Minus, something's wrong here. This is plus. You guys have got to catch me on that. Because both of these, this one's negative, because both of these are negative, it's negative and it's plus 26k. Okay, be careful. So we're going negative 22k minus 26k. Ian, is that a question? So that's minus 48k. And then we're going k squared minus k squared, groovy, even better, equals 0. So far, so good. Then we're going to go negative 48k equals 48, and k equals negative 1. There's one answer. Okay, worries? Again, you don't have to take notes on this if you don't want to. I'll put it online tonight. All right, now that we have 1, guess what we can do next? We can substitute again. I'm going to go a different color. Substitute again. We can substitute 0, 11 into, no, I lied. Let's go, well, yeah, 0, 11 works. But let's do it this way first. Let's go substitute negative 7, 4, and 0, 11. I like that better. Into x, what did we just found? We just found k. Okay, so we can do that. We still have x minus h squared plus y plus 1 squared equals r squared. So why is this plus 1? Yeah, because this right here is y minus negative 1, really. Okay, and that becomes y plus 1. Okay, worries on that? All right, so we're going to substitute this in, and we're going to get negative 7 minus h quantity squared plus 4. Yes, negative 7 and 4 are ordered pairs. They got to go together. I put negative 7 here. I got to put 4 here. Plus 1 squared equals r squared. Okay, and then the other one was 0 minus h squared plus 11, yes. 11 plus 1 squared equals r squared. Okay, once again, happy days. We can subtract this. Okay? We can subtract this, and life is good. I've got to think, maybe this one we might want to do another step. Is that better? Yeah, probably. I'm not ready to subtract yet. I mean, we're going to subtract it, but I think we better clean this one up because it's going to get messy otherwise. Okay, so I'm going to do all of this over again down here. Okay. So now I'm going to go negative 7 minus h squared plus 5 squared equals r squared. Let's do that out. Let's do that out. I keep changing my mind. I'm going to go negative 7 times negative 7. There we go. Plus 5 squared equals r squared. And then down here, I'm going to go, well, 0 minus h squared. You know that one. That's just h squared plus 11, no, 11 plus 1, 12 squared, right? 12 squared equals r squared, okay? So far, so good. Now, let's then multiply this out. Let's FOIL this. What do we get? We get 49 plus 14h plus h squared plus 25 equals r squared. Check me on that because I will make mistakes. Negative times negative, negative times negative, negative times negative, plus h squared. Yeah, that's right. Okay, and then we go, I was going to go green this time, minus h squared. No, that's ugly. Minus h squared plus 144 equals r squared. Okay, and again, we're going to distribute that minus. That's everything. Okay, what do we have left? What do we have left? 49 and 25. What's that? No. We've got, let's put it all out here. 49 plus 25 minus 144 plus 14h plus h squared minus h squared equals 0. I can see that. All right, let's try to clean this up. What do we got? 49 plus 25 minus 144, how much? 74. Negative 70, thank you. That sounds right. Negative 70 plus 14h equals 0. We're good there. Then we get 14h equals 70. Then we get h equals 5. There's another number. We're on fire. We're on fire. So now we've got h is 5, k is negative 1. What do h and k represent? Coordinates for the center of the circle. So we know we're negative 1 and 5. What's the only thing we need? Okay, we have the center. Let's find the radius by substituting. No, k goes with y. H represents the horizontal part of the center coordinates, and k represents the vertical part. Okay, and thanks for asking. Okay, good. Let's go. Let's substitute 0, 11 into x minus 5 squared plus y plus 1 squared equals r squared. Did I do that right? H is 5 and k is negative 1. Okay, we're good. We're good. And then the x part here is 0 minus 5 squared plus the y part is 11 plus 1 squared equals r squared. This is 25 plus, oh, this is a classic old one. Man, I'm almost disappointed. 25 and 144. This is the 5, 12, 13 Pythagorean triple. Man, boring. Okay, there it is. What's the final, ultimate equation of this circle? What's the equation for this circle? Okay, you're done. You're frozen, Carolyn. Good call, plus. That's right. Say it. No, equals 169. Be careful, because remember, it's equals r squared. Okay, so it's 13 squared. That's major. Whoo, man. That is a beautiful problem. Beautiful problem. Hey, but wait, there's more. As a bonus. Okay, like, who's got bad teeth here? Trevor. Perfect. You got bad teeth, and I have the same thing. You probably didn't know that. Anyway, when you go to an oral surgeon, what do they tell you? Your teeth suck. What should we do with them? Extract them and take them out, because surgeons want to cut. It's what they believe in. It's what they trained in. It's their philosophy in life. When you go to an orthodontist, what do they want to do? Fix what you got with braces, of course, because orthodonture is about adjusting and moving teeth around. Well, math is the same way. This problem we just did, what is this? This is all algebra. So an algebraist, which our author is, would say, this is how you do this problem. But would you believe it if I told you there's a much simpler way to do it? There is. Okay? There is a much simpler way to do it. And you have to think not like an oral surgeon. You have to think like orthodontist, which in this case, the analogy is a geometrist. A geometrist would go like this. Okay, you had a point at where? 0, 11. Haven't heard it yet. Negative 7, 4. Thank you. Man, get with it. Okay, so we have these points, right? And I'm going to hide this one because it doesn't count. I'm going to hide both of these because we don't need 0. Display hide points. Okay, so here is 0, 11. Here's 0, negative 13. And here is 5, 6, 7, 4. Is this correct? Okay, now, a geometrist would say that this point here and this point here, if you have 2 points on a circle, what are they? What are they called? 2 points. Chord. Chord. These are chords. Okay? And a geometrist would say, I know that the perpendicular bisector of a chord goes through the center of the circle. So I'm going to construct the midpoint right here. And a geometrist would say, I know then that I can construct a perpendicular line. Okay? So what would I do with this next chord here? Same deal. I would construct a segment. I would construct a midpoint. I would use the segment and the midpoint to construct a perpendicular. I would use the 2 perpendiculars and then do what? Intersection. And what are the coordinates of that intersection? Hmm. All right, hang on. We're not done. We're not done. We have our center point. Emmanuel, question. You could. You can do it with any chords. Any chords. They all will go through the center. So yeah, you could construct a segment here and do it again. That's a great question. Okay, now we need, though, however, we have this point. We can do this one here. It's fine. And this point, we got to construct a radius. And then we can say center here, radius here. And with that information, we can construct a circle. And what's the radius? What is this? 15, 16, 70, 18 minus 5, 13. And that, ladies and gentlemen, is a geometric solution to an algebraic problem. And this concludes our recording for today. We kept it under 21 minutes. Thank you for listening.